As you can see, there are many different ways that we can assign an IPv6 address to a router interface. And the first method we'll focus on is manual assignment. And as you may have guessed, manual assignment is all about statically configuring an IPv6 address on a router interface. So let's look at this example in our live environment. We'll focus on R4, which is connected up to ISPA, because this discussion is all about getting that provider assigned IPv6 address on our router interface. So the interface we're focusing on here is interface fast Ethernet 3/0. Let's look at the output of show IPv6 interface brief. And we can see here that fast Ethernet 3/0 has no IPv6 address assigned at all right now. So the service provider has given us the 2001:A:/48 address space. And as you can see, we've broken that up. We've divided it up into a whole bunch of /64 networks in our organization. Well, the link between our router R4 and ISPA is going to be the 2001:A:/4:/64 network. So as a result, we need an IP address within that 2001:A:/4:/64 address space. The ISP is already using an address in that subnet. So let's go ahead and configure, in this case on R4, the IP address associated with fast Ethernet 3/0. Interface fast Ethernet 3/0, IPv6 address. And in this case, we are going to specify the IPv6 prefix, because it's not the link local address we're configuring here. We are going to allow the link local address to be automatically defined by the router itself. So in this case, it's the global IPv6 prefix we are configuring. So they're looking for the /64 notation here. We are also looking for the subnet portion and the interface portion, or the network portion and the interface portion, in this case with our manual assignment. So we're going to say 2001:A:/4, and then after that, that's the interface portion, or primarily the interface portion. That's the subnet, or the network portion here. What's the interface portion? I have to come up with another 64 bits. That could be a lot. So the manual assignment method is difficult. It's cumbersome. It's a lot of work. It's prone to errors. Luckily, in this case, my last 64 bits are just going to be a whole bunch of zeros followed by the binary bits to make it equal to 4. So relatively simple for myself in this case, but in your organization, when you have a lot of devices in that particular subnet or in that particular /64 network, what do we end up with? We end up with a lot of work on our hands and potentially a lot of issues. But we can see here, it accepted the address. If we look at the output of do show IPv6 interface brief, we have the address assigned right there, and we have the link local address that was automatically generated. Now, how did the interface portion of that link local address get automatically generated? It used EUI64 to accomplish that. We can do that as well when we are manually defining the IP addresses on the router interfaces. So let's remove that IP address, no IPv6 address. Let's double check to make sure it was removed. It is. And let's reissue the same IPv6 address command we did before, but instead let's leave the interface portion blank. So I'm just specifying here the network portion, and then we're going to say EUI64. EUI64 tells the router automatically generate the interface portion yourself using the IEEE EUI64 standard, which is take the MAC address of the interface, break it in half, add FFFE to the middle of that. Now you have a total of 64 bits to fill in that interface portion, because the MAC address is only 48 bits. Now it's 64 when you add the FFFE. And then the 7th bit from the left, flip it. So if it's a 1, change it to a 0. If it's a 0, change it to a 1. So there's two things that have to happen. Changing the 7th bit from the left and adding FFFE in the particular MAC address of the interface. And then once we do that, and we look at the output of show IPv6 interface brief, we'll see now that the interface portion was automatically assigned by the router using EUI64. So in the real world, folks, should you go with the static assignment of that interface identifier, or should you use EUI64? Well, I'm going to steer you towards EUI64 for two reasons. Number one, it's easier. You don't have to pull out your Excel spreadsheet and come up with a whole bunch of unique interface identifiers for all the devices in your network. But number two is security-based. If you have to spend the time coming up with these unique interface identifiers, you might simply go with :1, :2, :3, :4, :5, :6. You see what's happening here? You are making your globally visible unique IP addresses predictable. Meaning that malicious user, since they know your network ID of 2001:A::A, or pardon me, 2001:A::A:4/64, they can now easily guess the IP addresses of the users inside that network. So by using EUI64, you are obscuring those addresses a little more. They can't be guessed. Now, notice I said guessed, okay? They could still be determined or figured out based on looking inside the packets that are flowing in and out of the network. But you are omitting the ability for them to simply be guessed and an attack being generated based on the guessed IP address. So definitely easier to configure. And number two, you have that added bit of security. Another thing you want to avoid doing is using the IPv4 addresses that you have in your network as the interface identifiers. So for example, you wouldn't want to use 2001:A::A::4:0 and filling in the last 32 bits with something that would represent the same private IPv4 network that you have in your organization, because then again it leads to the ability of malicious users to determine those IPv4 addresses that are being used in the network as well. So to protect yourself, avoid having your private IPv4 addressing information in your globally unique IPv6 addresses.